Welcome to part 2 of the topic 6 test review. This is for problems 10 through 15. So if you need help on problems 1 through 9, please see part 1 of this video. Let's get started. So for 10 through 15, what we're doing is we're finding the solutions to the equation. And we also need to eliminate any extraneous solutions. So since it doesn't specify which method to solve by, for 10 through 12, I am going to solve algebraically. And then 13 through 15, I will solve by graphing, so that way we can get a taste of both. So starting with number 10, I'm going to start by adding this 8 over to the other side, because that 8 is on the outside of my square root. And we always want to isolate the square root first. So now, when I move the 8, I am left with square root of x minus 10. And that is now equal to a positive 3, because negative 5 plus 8 is 3. Now that my radical is isolated, I can square both sides, and the square is going to cancel with the square root because those are opposites of each other. So I'm going to get x minus 10 is equal to 3 squared is 9. So then I'm going to add 10, and I get x is equal to 19. And so I got an answer of 19, but now I need to double check it with my original function. So I need to plug it back in. So square root, instead of x, I'm going to plug in 19. So 19 minus 10 minus 8. And we're going to see if it equals negative 5. If it does, this works. If it doesn't work, then this is an extraneous solution. So to keep it easy, I can just plug the whole thing in my calculator. So square root of 19 minus 10. Hit the right arrow to get outside, minus 8. And we'll see if that gets us a negative 5. And it does. So this works, so that means this is our answer. So looking at 11 and 12 again, we're going to do the same process. I have to isolate my square root first, so I'm going to subtract the 2. And so then I'm going to get the square root of 2x plus 6 is equal to 8 minus 2 is 6. I got to square both sides now because my radical is now isolated, so cancel that out. And I get 2x plus 6 is now equal to 6 squared is 36. I'm going to subtract 6 over, and so I'm going to get 2x is equal to 30. Divide by 2, and I get x is equal to 15. So once again, we have to double check this answer since we solved algebraically. So to plug it in, this is going to be 2 instead of x, I'm going to plug in 15. So 2 times 15 plus 6 plus 2, and we're going to see if it equals 8. So again, I can use my calculator to make it quicker. So 2 times 15 plus 6, and then on the outside is a plus 2, and does it equal 8? Yes, it does. So this works, so that means this is my answer. So 12, same process. Again, we have to get the radical by itself. So we're going to get rid of this negative 4. So we're going to add 4. Even though there's a plus sign right there, this 4 is negative. So to get rid of it, we're going to add 4. And so we're going to get square root of x minus 7 is equal to negative 2 plus 4 is a positive 2. My radical is isolated, so I'm going to square both sides. Cancels on this side. So x minus 7 is equal to 2 squared, which is 4. Add 7 to both sides to get x by itself. We get x equals a positive 11. So let's go ahead and double check it like we've done before. So negative 4 plus the square root of x minus 7, which we are going to plug in 11, minus 7. And let's see if it equals negative 2. So negative 4 plus the square root of 11 minus 7. Does it equal negative 2? Yes, it does. This works, so this is my answer. So now looking at 13, 14, and 15, I said I would solve these by graphing so we can try out both methods. For these, since you solve by graphing, you do not have to check for extraneous solutions, because extraneous solutions do not show up on the graph. So starting with 13, excuse me, You can move the 7 over if you want. You could add 7 And you could type this in as 4x plus 33 equals x plus 7. If that is easier for you just to get your square root by itself, go ahead. You don't necessarily have to. Since I already did, I will. So in y equals, I'm going to put square root of 4x plus 33 in y1. And I'm going to put x plus 7 in y2, so x plus 7. And let's see if we can see the intersection on the graph. So I can see an intersection. There's one right here. So I'm going to do second trace 5. And I'm just going to get this cursor. I'm going to use the left arrow, get it as close as I can, kind of estimate it. And I'm going to hit enter 1, 2, 3 times. And I get x is equal to negative 2. Again, we don't have to double check our answers. So x equals negative 2. I do not care about the y value because there's not a y in this original function. So there's no solution for y to be found, okay? So that only shows up because we graphed it. We don't actually care about it. 14, there are 2 square roots on the same side. Please, please, please move one of them over to the other side. So I'm going to add square root of x. So what we're going to graph is we're going to have 3x plus 1 is equal to 3 plus square root of x. Please write it this way. It makes the graph a lot easier. So we'll put this in y1. We'll put this in y2. So back to y equals, clear out our last problem. And we're going to do square root of 3x plus 1. And in y2, we're going to do 3 plus the square root of x. And let's see if we can see the intersection. So you notice the intersection is not quite visible, right? These lines are getting super close, but we can't see it on the screen. So this is one of those scenarios where we're going to have to adjust our window. So I'm going to try 20. If I adjust it to 20, see if I can see the intersection. And I can see it now. It's somewhere in this region. So now I can do second trace 5. Again, move my cursor over. All right. I know it's somewhere in this region, so we'll call this good enough. Enter 1, 2, 3 times. And I get x is equal to a positive 16 as my answer. So 14 is an example of it may not always be visible on your normal window, so you may have to adjust if need be. 5, we don't need to do any adjustments. We can we can type it in as is if we would like. So we can have just 5 on one side, and then we'll have square root of x and plus 3. You could move the plus 3 over if you would like, but not a requirement. And probably don't need to keep the adjusted window, but there's no point in changing it back. I can see my intersection right there, so second trace 5. It actually is pretty close, so 1, 2, 3. So it says x equals 4, so we're going to say x equals 4, and that is my solution. Okay? Now, just a reminder, starting on this test and moving forward, there will be no notebooks allowed. So please make sure on the rest of this page I give you right here, all right, on the rest of this page, you have all of this blank space, and then on the back of this page as well, when you print it out, write down any notes you need. Write down anything. Calculator steps, any little hints, any steps to solving an inverse, whatever you need. Please write it down here because no notebooks. If you have any questions or concerns or anything, please reach out to your teacher. Otherwise, have a fantastic day.